All right. All right, I think we're rolling now. So we are continuing. Now I got to get my notes out. Sorry. Bear with me. I'm new to all this. Let's see. There we go. And since we went over the quiz, I'm not going to go over that homework. Just hang on to, just hang on to it. I'll have you turn it in tomorrow, okay? And today's. If we get finished today, I'll have you turn that in too, all right? So, you can go back and look at Renway. You shouldn't have to ask me. So it's section, this is R4. All right, so this is section R4. And let's turn the pen on. There we go. All right, we should be ready to go. Let's make that go. There we go. All right. Yes. Oh, yeah, that's right. I said we're going to have a quiz tomorrow, didn't I? I know, yeah. Let's not have a quiz tomorrow. Okay, so no quiz tomorrow. We'll have it on Monday. All right, be here on time on Monday. We'll have it on Monday. We'll talk tomorrow a little bit more about the quiz. Okay, but I'm just out of time to go over any of that stuff. So we've got to get started. All right, let's do this. We're still going to multiply. The last thing we did was multiply polynomials. Oops, let's turn this on. Or actually, just hook it up to me. Might sound a little bit better. Okay, so the last time we talked about multiplying polynomials. So this is part 2. So I'm going to put a part 2. All right. This one we're going to do, they call them special products, special ones. These are ones that'll show up every once in a while. And if you learn how to recognize them, it may be a little bit easier. So let's do this. And you've probably heard this before. We might have even mentioned it yesterday or Monday. All right, what if I ask you to multiply those two things together? All right. You got two binomials being multiplied together. We have a special name for that. Does anybody remember? It's a mnemonic device. Each letter stands for something. Do you remember what this is? FOIL. Very good. You learned this, right? Okay, it's FOIL. So F is what? First, outside. A lot of people say outer. I say outside, and then inside, and then last. Okay, I won't write that down. You can write it down if you want. First, outside, inside, last. So what in the world does that mean? Well, it means that's the order that you multiply. So you take the first binomial and you multiply the first things together. That would be this and this. Remember, this is acting as one thing. This is acting as one thing. All right, so you take the first, you multiply it together. Then you take the two on the outside. It's basically just distributive property, but some people like to say FOIL. Okay? Trey, do you want to watch this, or you just, okay, get your head up then. So that's the outside. So that's your first. These two right here are your first. This one right here and this one right here are the outside. And then these are your two inside ones. You multiply them, and then these are your last ones. So you can remember FOIL, but to tell you the truth, if you never learned the word FOIL for this, you could still learn that this is just distributive property. And we did one like this on Monday, except I think we had a binomial and a trinomial. But this is really a popular, if you want to call it, a popular product, a special product that we encounter a lot. And a lot of people love to use the word FOIL, and that's what it is. So let's actually do the multiplication. So let's do the first, AX times CX. So the A and the C are multiplied together. X and X are multiplied together, but what is that? That's X squared. So we write X squared. Let's do the outside. The outside is AX times D. And it's plus because they're all positive on this one. So it's AXD. And then let's do the inside. The inside are these two right here. So it's BCX. Doesn't matter what order you put it in. I just do the order that it's already sitting in right now. Put a plus because, again, they're both positive. Then you do the last. The last two terms are the B and the D. So I put BD. Are there any like terms here? You're like, well, I got an X here and an X here, but you got this AD and AD. If they're regular numbers, you could probably add them together, right? So this is just like your very general formula, all right? So that would be it right there. So that's basically what FOIL is. Let's do a real problem, all right, instead of all that mess. It's always easier when you see regular numbers So everybody got that written down? I'll leave it right there for you. All right, so let's do a real problem. These are the ones that are kind of special. All right, x minus 3, x plus 3. This is really important. You're going to see this a lot. All right, but you're going to see it the other way. Do you remember doing factoring in Algebra 2? You probably did that in Algebra 1 as well, didn't you? Factor stuff. This is going to be one of those factoring things, but we're not going to talk about factoring just yet. In a few days we will. Let's do the FOIL method. I'm not going to do all those lines like I did before. But let's just do it in our head. The first, x times x, which is x squared. The outside, which is positive x times positive 3. I always like to put the number first. Okay, so we put the coefficient first. That's positive 3x. That's the outside. Let's do the inside. This time it's a negative 3 times a positive x. So we're going to put a minus and then a 3x, because 3 times x is 3x. And then do the last. The last is negative 3 times positive 3, which is negative 9. We're not finished. We got to look to see if we can simplify it. Do we have any like terms here? What about the x squared? Are there any other x squareds? Nope, so we just write down x squared. What about the x's? Sure, we got a plus 3x and a minus 3x. Remember the rule for that? Well, they cancel out, but the rule is when you add exponents, or when you add like terms, you just add the coefficients, right? And you keep the term. So if I add coefficients, it's a positive 3 minus 3. What is that? It's a 0. And 0 times x is 0. If you want to look at it as they cancel out, it's okay. But I want to make sure that you understand why they cancel out, because they add up to 0. If you wanted to, you could put a plus 0 here. I'm not going to bother doing that. If you want to look at them as, oh, they cancel out, that's okay too. All right? And then what else is left here? Minus 9. And then that's your answer. What we're going to do eventually in the next few days is we're going to start with this, and we want to end up with that. Okay? They call this the difference of two squares. Yeah, they talk about it in here. Let's write that down. The difference, I'll just put diff. The difference of two squares. S-Q-U-A-R-E-S. All right? If you look at it, why is it called the difference? Because what's this? It's a minus sign, and what's the big fancy math word for subtraction? It's the difference, right? The answer to a subtraction problem is the difference. All right, so that's why they call it the difference of two squares. Look at this. You're squaring something to get x squared, aren't you? You're also squaring something to get what? To get 9. All right, that's why they call it the difference of two squares. So eventually you're going to look at this and recognize that, oh yeah, that's a difference of two squares. It factors to be this. We're not there yet, but I'm just giving you a sneak preview. All right, it's just the multiplication is what we're doing today. All right, let's do another one. I think this is example 7, and they give you a whole bunch of them. I'm going to do this one. This is B. So this is example 7B. If you look in the book, so it's x plus 2 squared. Now this really tricks people up a lot, and you got to pay attention to this. It's not hard, but you got to pay attention. A lot of people think, oh, you just square everything in the parentheses. That's what a lot of people think. With the way I'm saying it, do you think that's right? No, it's not, okay? A lot of people think you just go, oh, x squared plus 2 squared. No, that's not it. Everybody hear me on that? Okay, I want to stop that mistake right now. Let's stop it in its tracks. You cannot just go x squared plus 2 squared. What do you do when you square something? Like if I had a 3 and I squared it, what are you really doing to that? By itself. Very good. That's what I wanted to hear. It's 3 times 3. You multiply it by itself. What are you doing to this parentheses? You're squaring it, so you're doing what? You're multiplying it, talk to me, by itself. Wow, that was weak. All right, so it's multiplied by itself. So what do? We write x plus 2 times what? X plus 2. Multiplying it by itself. That's so important. This is a huge mistake students make all the time. They just think that they can distribute this squared through everything in the parentheses. This is not a distributive property problem. All right? Exponents, there's no distributive property for exponents, only for stuff that's being multiplied. All right? So this is how you write it. Now we're back to what we just did. Let's do this super quick because I got some other ones to do. First, outside, inside, last. Okay, the first is x squared. The outside is 2x positive. The inside is also plus 2x. Then the last is plus 2 times 2, which is 4. You could have done that in your head probably. When you do more of these, you should be able to do that in your head. I'm just showing you the steps right now. So it's x squared plus, what's 2x plus 2x? It's 4x, and then plus 4. And then that is your answer. Do you see? That's a lot different than just x squared plus 4. You got that middle term right there. That's super, super important. Okay, why didn't you have a middle term on the other one? Because the middle terms actually added up to 0, because you had a positive and a negative. When you have all positive, it's not going to add up to 0. It's impossible. All right? Does that make sense? Ask me if you don't understand. Let's do one more. Yeah, basically. Well, yeah, let's do one more and then we'll do something different and then we'll end. We got 6 minutes, so let's see if we can get this done. Which one do I want to do? This one right here. So it's 2x plus 1, and we kind of did something like this similar on Monday, so this really isn't that new. You could just think of it as distributive property. Okay, but this is a FOIL because they're two binomials. When you multiply two binomials, that's the FOIL. All right, so let's do it kind of quick. So the first is 2 times 3, which is 6, x times x, which is x squared. That's the first. All right, it's 2x times 3x is 6x squared. Let's do the outside. The 2 on the outside are 2x times 4. Well, 2 times 4 is 8, and it's a plus because they're all positives here. And then it's just an x. It's 8x. Let's do the inside. It's 1 times 3x, which is just 3x. Let's do the last. It's just a positive 1 times a positive 4, which is 4. Let's add up some like terms if we have any. And we do. These two right here are like terms, so we got to add those up. 8 and 3 is 11, and it's 11x. And then you put the plus 4 on the end, and that's all there is to it. It's basically just distributive property. It's nothing new. It's just kind of special because you got two binomials, and we use the word FOIL a lot for that kind of thing. All right. So now there's some more examples. If you want to look at the examples in the book, go over them, see what they did, figure out how to do them yourself. They got the answer right there. Feel free to go ahead and do that. I'm tired of this yellow. Let's go to this light green. All right. Actually, I didn't hit it, did I? There we go. All right. Let's do another one. Watch this. But this is not squared this time. This is cubed. Just like we said earlier, you can't just go x cubed plus 2 cubed. You can't do that. What do you do when you cube something? We already talked about this when we went over the quiz. What's 2 cubed? It's 2 times what? 2, which is 8. All right, but this is what I want you to look at. When you cube something, you multiply it by itself how many times? 3 times. So let's rewrite this. So it will be x plus 2 times what else? X plus 2 times what else? X plus 2. All right? That's what it means. All right? Now you got 3 things being multiplied together. What I would do is this. In your head, well, maybe not in your head. See this part right there? I would do that first and just leave this x plus 2. Don't try to do all 3 of these at one time. Okay, just break them up into 2's. So right here, I would put x plus 2, keep it in parentheses, and then let's figure out what all this stuff's going to be. All right, this is just FOIL method. We could do this in our head now, can't we? X times x is x squared. Outside and inside. What's the outside and inside going to add up to be? Plus 4x. Right? Outside and inside, 2x plus 2x. Yeah? And then plus 2 times 2 is 4. Now, we're not finished, are we? Now we have to multiply this stuff together. And we could do that. It's just distributive property, right? It's just take the x and multiply it by everything, and then take the 2 and multiply it by everything. We did that on Monday. So let's go back to our green, and let's take the x and multiply it through all this. So x times x squared is x cubed. X times 4x is 4x squared. X times 4 is 4x. That should be something that you walked into this room first day of school knew how to do. Plus, but if you don't, I'm showing you now. Plus, take the 2 and multiply it through here. Plus 2x squared. Then 2 times this, which is 8x. And then 2 times the 4, which is the 8. And now we have to look to see if there's any like terms to add up. We can't leave it like this. I'll mark it wrong. If you don't simplify it, I'll mark it wrong. Look at the x cubed. Are there any other x cubes here? Nope. So we just leave it x cubed. What about x squared? Do I have any other x squareds? Sure. 4x squared plus 2x squared, which is 6x squared, because we're adding. And then the 4x plus the 8x, that's a plus 12x. We're done with that. And then what else? Plus 8. And you are finished. That's how you do it. All right. That's basically it. That's basically it. So let's do homework. So homework. It's pages 28 and 29. Now you should have finished Monday's homework. Listen, you should have finished Monday's homework already. Technically it's due today, but I'll let you sit on it and turn it in because I would like to go over some questions with it, okay? So I'll let you turn that in tomorrow, yesterday's, but this is officially tonight's homework, okay? And you're doing 47 to 87 odds. Nah, just wait till tomorrow.
What's the pages?
28 and 29. Yeah, my 8s are weird. I don't know. I always made weird 8s. So I gotta get really slow about it to make a nice looking 8. When I do it fast, it looks terrible. So that's it right there. Your homework is page 28 and 29. I'm sorry. Oh, my, not 28 and 29. What am I doing? Where was I looking? 48. 48 and 49. Wow. Forget 28. It's 48 and 49. And it's 47 to 87. I think all the rest of that is correct. It's on RenWeb, all right? If you ever have a question on what your homework was, don't come in and ask me. You should have already looked. Excuse me. You should look on RenWeb. If you don't have RenWeb, I mean, you should. But if you don't, look on the YouTube, all right? Go to the YouTube video. I've always got it right here on the YouTube video. All right. Well, that's it.